Welcome to our deep dive. Today, we're going to be looking at how to evaluate those large language models, LLMs, fairly.
Yeah.
They're trained on massive amounts of code, but that brings up a problem.
Right.
What if we test the models on code that they've already seen?
Exactly.
That's where the Heap comes in.
Yeah.
It's this new data set, and it's built to avoid this very problem.
Right.
So today, we're going to really get into that. Understanding this is key to knowing just how trustworthy these LLMs really are.
Yeah, I mean, that's exactly right. Data contamination, that's what we call that problem.
Right.
And it can make a model seem like way smarter than it actually is.
Yeah.
Imagine if you took a test, but you'd already seen all the answers.
Oh, yeah.
Your score wouldn't be accurate.
Right. Okay, that makes sense. But with so much code out there, how can we avoid contamination?
Well, the data sets are massive, like really huge.
Yeah.
Like there's one popular data set called the Stack with 3 terabytes of code. As these data sets keep growing, it gets harder to find new unseen code to test these models on.
Yeah, it's like you're trying to find a brand new recipe when the internet is already full of recipes.
Exactly. And that's why the heap is so important.
Yeah.
It tackles contamination in 2 ways, really smart ways.
Yep.
First, it only uses code that has these like non-permissive licenses, like the GNU General Public License. And these licenses, well, they discourage people from using that code to train LLMs because of, legal issues and stuff.
Oh, okay.
So it's less likely that that code already been seen by the models.
So it's like you're building a test from a secret cookbook, a cookbook that most AI trainers don't even have.
That's a really great analogy.
Oh, good.
And the second thing they do is they've deduplicated the heap.
Okay.
So they removed any code that's found in other common training data sets. So what you have is totally unique code.
Okay.
This way, we can test LLMs on code they've never encountered.
Yeah.
And that gives us more accurate insights into their actual abilities.
Okay. Wow, this sounds incredibly thorough.
Yeah. So how do they even go about finding this code?
Well, they used the GitHub API, but they were very specific about what they were looking for.
Okay.
They wanted repositories that had those non-permissive licenses, and they focused on, all sorts of different programming languages, like we're talking about Python and Java, but also some less common languages with different syntaxes, different programming paradigms, even some super specialized languages.
Wow, that's a diverse set. So all this code is coming in. How do they make sure there are no duplicates in the data?
So they used 2 approaches.
Okay.
The first one is called exact deduplication.
Okay.
It's kind of like plagiarism detection for code. They use these things called SHA 256 hashes to find any files that are exactly the same as the ones in other data sets, even if they look different.
So they're catching the blatant copycats.
Exactly. And then the second approach is called near deduplication.
Okay.
It's a little more nuanced. Think of it like a super-powered plagiarism checker.
That can spot similarities even if the code's not 100% identical.
Right.
So for this one, they use something called min-hash locality-sensitive hashing, LSH for short, which is a mouthful.
Right.
This helps them to find snippets of code that are super similar, even if they're not totally the same, so nothing gets through.
So what information is actually in the heap for each piece of code?
Well, it's not just the code itself.
Okay.
They have the code, the file name, the path within the repository name, and even these things called quality indicators, like the number of lines of code, how long each line is on average, and the number of stars a repository has on GitHub. These are like metrics that kind of show how well maintained and relevant the code is.
So researchers can be picky about the code they use.
Yeah.
Okay, very cool. Anything else they include?
Yeah, they also include those duplicate flags we talked about.
Right.
So it's super clear if a file is a duplicate. Makes it easy for researchers to filter them out.
The Heap sounds like a fantastic resource. But is there anything they're looking to improve?
Yeah, the team is really dedicated to keeping it up to date.
Okay.
They're going to check it against any new training data sets as they come out to make sure it stays contamination-free.
That sounds like a lot of work. But it's essential. Anything else?
Yeah. They're also looking into more advanced deduplication techniques. They're trying to find ways to catch duplicates at an even finer level of detail. Like imagine finding copied code, hidden within a bigger file.
Oh, wow.
That's the kind of stuff they're working on.
It's like they're code detectives. What about the quality aspect? Are there plans to improve that?
Oh yeah, for sure. They want to find ways to clean up the data, remove low-quality code. Think about automatically generated code or repetitive phrases.
Okay.
They want to focus on the code that really reflects human, problem-solving and creativity.
So they're making this data set the ultimate testing ground for LLMs. That's really cool. But before we get too carried away, we got to talk about the ethical considerations here.
Yeah, absolutely.
There are definitely concerns about using publicly available code to train these models, especially without the developers, explicitly saying it's okay.
Yeah, a lot of developers might not even know their code is being used this way.
Right, right.
But the Heap, it tries to be more ethical. They give repository owners the choice to opt out of having their code in there.
That's a great first step. But is there any kind of consensus in the community on how this opting in or opting out should work for code data sets?
Not really. It's a tricky issue, no easy answers. The AI community is still figuring out how to balance the benefits of having this open source data with, the rights of individual developers.
Yeah, it sounds like there's a lot to consider here. Let's zoom out for a second and talk about what all of this means for LLM evaluation as a whole. Why should someone who's interested in LLMs, why should they care about all this?
Well, because as we've seen, evaluating these models correctly is super important for their development and for knowing how much we can trust them.
Right.
We got to know if they can actually handle new code, solve problems they haven't seen before.
Because if they're just repeating code they memorized, it's not real intelligence.
Exactly. Yeah. It's just a trick. The Heap helps us make sure we're getting an accurate view of what these models are actually capable of. It pushes them to their limits,
Yeah.
Tests their ability to, think for themselves.
So it's about making sure we're seeing the real potential of these models.
Yeah.
But I feel like there's still more to talk about.
Right.
What about all those sneaky duplicates the Heap might miss?
We're going to dig into some of these challenges and what they mean for the future of LLM evaluation in part 2 of our deep dive.
Sounds good.
So we were talking about how the Heap tries to tackle, code duplication.
Right.
But it got me thinking,
Yeah.
what about all the code that's, not publicly available, not in these repositories?
Yeah. Could that still be causing contamination?
That's a really good question. And it kind of gets at, even bigger challenges when we're talking about LLM evaluation.
Yeah.
The Heap's a great step, but it's mostly focused on contamination that we know about
Yeah.
from, data sets that are public.
Right.
But there's so much code. Think about private companies, their projects.
Yeah.
Or, snippets of code on forums, message boards, or just, code that hasn't even been uploaded anywhere yet.
Right.
It's out there.
So even with the Heap, there's still a chance that an LLM could have seen similar code during its training.
Yeah, it's totally possible. It's kind of like trying to put together a puzzle, but you're missing some pieces.
Oh, yeah.
You try to get the full picture, but there are always going to be gaps.
That makes me think, as more and more new code is written every day, that potential for contamination is just going to keep growing, right?
Yeah, you're absolutely right. It's this constant, game of catch-up. And it brings up, these really big questions about how we even evaluate these models. How do we really figure out if an LLM can generalize when the stuff it might have learned from just keeps getting bigger and bigger?
It sounds like almost we need a whole new way of thinking about how we evaluate. It's not just comparing code files.
There's a lot of researchers are looking into other methods. Some are trying to measure the novelty of a piece of code.
Oh, okay.
Basically, how different is this code from anything the model might have already seen?
Right.
Others are going deeper, analyzing how the model works on the inside, trying to see if it's actually understanding the concepts behind the code or just, memorizing snippets.
So it's more than just looking at the surface. It's like you're trying to peek into the mind of the LLM and see how it's really working.
Yeah, that's a great way to put it. But this is where things get even more complicated.
Oh, okay.
LLMs are so complex.
Yeah.
Even the people who build them don't fully understand how they work all the time.
It's almost like trying to understand how a really brilliant artist thinks. You can look at their technique, their brushstrokes, but there's this magic to their creativity that's really hard to grasp.
I love that analogy.
Yeah.
And as these models get even more powerful, more complex, it's going to be even more important to have really good, insightful ways to evaluate them.
So where does that leave us?
Yeah.
Is it even possible to have a truly contamination-free evaluation when all this data is constantly changing and evolving?
It's a really tough question. The research community is really wrestling with this. Data sets like the Heap are super valuable, but they're just one part of the solution. We need better ways of analyzing these models, really getting a deep understanding of how they behave.
It's like we're at this crucial point where
hmm
we're figuring out what LLMs can do, but we have to be really careful. We got to make sure we have the right tools, the right methods to evaluate them in a way that makes sense.
I agree. The stakes are high.
Yeah.
These models, they have the potential to really change so much about how we live. But we can't just get caught up in how impressive they are, you know?
Mm.
We got to hold them to a high standard. We have to make sure that they're really as good as everyone says they are.
It's like a reminder that even with all this amazing technology, it's still really important to think critically and evaluate things carefully. So, so for our listener, what's the main takeaway here? What should they keep in mind as they're, learning about LLMs?
I think the most important thing is to remember that, LLMs are incredibly powerful,
Mm.
but they're not like magic. They learn from data, and
Hmm.
that data can affect them in ways that we don't always understand. So be aware of that. Understand that they have limitations. Recognize that there can be bias, contamination, and just, approach everything they produce with a little bit of healthy skepticism.
Good advice. As we're wrapping up this part of our deep dive, I want to encourage everyone to go check out the Heap for themselves. It's a fascinating look at how we evaluate LLMs,
Yeah.
and you might even start asking some new questions about how these models are shaped by, all the data they're trained on.
And who knows, maybe it'll even inspire some new ideas for dealing with contamination and making sure
Wow.
that these models are built and used responsibly.
Yeah.
Because ultimately, the future of AI
Mm-hmm.
is something we're all going to be a part of. We're all going to help shape it.
He'll love that. Well said. On that note, let's move to the final part of our deep dive. We're going to explore something about the heap that I found really interesting, which is the role of software licenses. Stick with us. So, we've spent all this time talking about the heap, how it's trying to make sure we're evaluating LLMs on code they've never seen before.
Right.
But I got to say, one of the things that really caught my attention was like the role of software licenses in all of this.
Yeah.
It's not something you typically think about when you're talking about AI,
Right.
but it's actually super important here.
It is. It's really interesting how something, that seems like a kind of boring legal detail can have such a big impact on this cutting edge technology. The heap focuses on code that has these non-permissive licenses.
Right.
And that's a very deliberate choice. And it has some interesting consequences.
Yeah, just to make sure everyone's on the same page, could you remind us what makes these licenses non-permissive?
Sure. So these licenses, they often have rules about how the code can be used, especially when it comes to commercial stuff.
Okay.
So developers might be a little hesitant to use that code to train LLMs because, they could get in trouble legally.
So it's almost like there's this built-in protection against just using any code you find.
Exactly. It makes companies think twice before just,
Yeah.
grabbing tons of code without considering the consequences.
Right. It kind of adds another layer of complexity to the whole data collection process.
It does.
And it's actually a good thing in terms of contamination. But it also made me wonder, what happens if those licenses change? What if those non-permissive licenses become more open over time?
That's a great point. Things are always changing in the world of software licensing. So the heaps strategy, it might not be as effective if those licenses change.
Yeah.
It's a good reminder that we got to be flexible and stay aware of what's happening in that space.
Absolutely. It makes you think about what other unexpected challenges might pop up as LLMs get more and more advanced and the data sets they're using keep changing.
Yeah, that's the big question, isn't it? It's like we're navigating uncharted territory here. We're constantly learning and adapting as we go. And it really highlights how important it is to have people from different fields working together.
Right.
Computer scientists, legal experts, ethicists, they all need to be involved to figure this stuff out.
It's a good reminder that AI isn't just about the technology itself. It's about us, and how we choose to develop and use these tools responsibly. Well, we've reached the end of our deep dive into the heap and the challenges of evaluating these large language models. Hopefully everyone listening has a better understanding of this constantly evolving field.
Yeah, and keep asking those questions. Stay curious. We can all play a part in shaping the future of AI in a way that's responsible and thoughtful.
I'm going to said it better myself. Thanks for joining us. Until next time, keep exploring.